Hello, my name is Terrellyn Parker, and I am a teacher at Evergreen Junior High School in Terrebonne Parish. As an educator, I am most passionate about the ideas that encourage a growth mindset and active learning. Also, meeting students where they are and giving them the tools and confidence to succeed. I strive to meet students where they are through scaffolding, Kagan Cooperative Learning Strategies, Milestone Math Bootcamp Academy by Cynthia Newman, meetings with my admin team, including Dr. Lakeisha Nelson, Ms. Lisa Holmes, and Mr. Mark Thibodeau, collaborating with math teachers, and multiple representations so every learner has the opportunity to succeed. I am currently teaching 8th grade math. Today's lesson is coming from the iReady Classroom Common Core Curriculum, Unit 4, Lesson 16, Session 2, entitled Develop Interpreting a Linear Function. The lesson objective is I can identify and interpret the rate of change and initial value of a linear function from a verbal description, an equation, a graph, or a table. I can also write an equation for the linear function. Prior to this lesson, new vocabulary was introduced, including initial value, and we were able to relate it to the y-intercept by getting the students to understand that they are the same. I was able to examine the exit tickets and see that only about 55% of the class mastered the objective, which helped me in planning for today's lesson. The overall goal for Lesson 16 is for the students to master relating slope to rate of change, y-intercept to initial value, write an equation in the format of y equals m times x plus b, and interpret a linear function from a real-world context. Graph, table, and equation. This session is delivering the concept and practice my students need to meet this goal. This particular class is honors with no accommodation requirements. I started the session with additional notes I felt were needed for the 45% of students who did not master yesterday's objective. I also have anchor charts and posters provided for additional assistance as well. I intentionally paired a student who was absent yesterday with an advanced level student to have a student-teacher relationship during partner time.
Alright, good morning and happy Friday. Welcome on in, guys. So the first thing we're going to do is we're going to go over some notes. And today we're going to be covering Lesson 16, Section 2. Okay, so let's go through some notes first. You should have this on your desk already. Slope-intercept form of a linear equation in standard form. That standard form equation is y equals m times x plus b. Point means what? So m, what is m, guys? Cooper, the slope. We can point it out. What is b? B is the y-intercept. Good job. So x is always your input and y is always your output, okay? Understanding slope. Slope is also known for linear functions, the rate of change. It's also known as the rate of change. So if it's positive, it's going up. If it's negative, it's going down. Good job. The y-intercept, that's my b. This is also known as the initial value. It's going to be very important for this lesson. Slope is the rate of change. The y-intercept is that initial value, okay? So my y-intercept is always x is equal to 0. So when written as the coordinates 0, b. So my example, y equals 2 times x plus 1. We can see 2 is our slope. We can see 1 is the y-intercept. So the line is going to cross the graph on the y-axis at 0, 1. So when we're interpreting a linear function, this is a real world meaning. Let's say, for example, y equals 5x plus 10. 10 is that starting value, that initial value, our b. 5 means the value that increases. It increases by 5 each time. That is the slope. So in a real world situation, we can say, hey, the starting cost for this one-time fee is $10. And then it's $5 every hour. Okay? So this is some little notes that you can have off to the side while we're going through today's session. Please go ahead and open up your workbooks to page, I think it is 361. 365. 365. Can I get a volunteer to read?
The slope, rate of change, and y self-initial value from functions, graphs, or equation in terms of the context.
Okay, perfect. All right, guys, we're on page 365. I'm going to give you 1 minute to do the try it problem. Nick is already ready for us, so let me put the timer up. All right, class, now I'm going to give you a 30-second turn and talk. I want you to turn and talk to your partner. Turn and talk to your partner. What do you think the height above ground is?
She starts at 90 feet, and as you see, she goes down from, I chose 0, 90, and a point 2, 80. And as you can see, it's 10 over 2, which is 5. So it'll be negative 5x, which is the slope and the rate at which she descends. Did you get those?
No, I did not. I was too busy trying to figure it out. So basically, I was going to use this one and like 60 divided by 4, but yeah, no, I got it completely wrong.
No, you don't divide it. So you chose this point and what other point?
This one. I know.
Alright, let's talk about it. Here we go. So it says Aretha is rappelling down the side of a cliff. The graph shows her height above the ground in feet as a function of time and seconds as she descends. If she's descending, what is she doing?
She's going down.
Cooper? Yes, she's falling down. She's coming down from this cliff. What is Aretha's height above ground when she begins rappelling down? Denzel? How many? Thumbs up if you agree, guys. We agree with that? Yes. Aretha's height above ground when she begins rappelling down is 90 feet.
So that if you, since it's 2, that if you divide it by 1, that it would be, sorry, 5 feet.
No, it's fine. It's fine. Can we add on to Lila's answer? We want to add on to Lila's answer. Owen?
So every 2 seconds, Aretha descends 10 feet. So we can take that into account that the x-axis is 2 seconds, and we have to have one single x to find our rate of change. So you would divide both sides by 2 to get 5 feet per second.
5 feet per second. Perfect. The rate is, Aretha is rappelling down at a rate of 5 feet per second. Excuse my handwriting, I do apologize. All right, did we answer everything, guys? Yes or no? Yes, we did everything for the try? Okay, perfect. So now we're going to go to the connected. The connected is actually on page 367. I'm going to give you 3 minutes to answer problems, questions 1, 2, and 3. And we may not even need the full 3 minutes. So let's answer questions 1, 2, and 3 on your own. And then we're going to come and talk about it, okay?
X and y represent this equation of the function. Okay.
Anybody want to add on to Nick's answer? I'm going to write it down. Oh, what you think about Nick's answer?
I find that one's good. You find the time and you find the feet labeled on the side of the graph. It should normally be labeled on the side of the graph. But like another big find is find out the constant rate of change. You can use that to help you determine the equation and what x and y represent.
Perfect. I agree. So I'm just gonna write out what Nick and Owen stated, okay? And you can double check your work, okay? Owen, you can go on to the next one.
Number 2, look at the model and analyze it. What is Aretha's height above ground when she starts rappelling? At what rate does she descend? How do you know? Molly?
Her height above ground is 90 feet, and she descends at a rate of 5 seconds. And you can see that on the graph because the graph shows where the line intercepts the y-axis, which is going to give you the initial value, and then the rate is the way that the line moves down.
Great answer. Snaps. Number 3, explain how to write an equation of a linear function when you know the rate of change in the initial value of the function. Lila. Okay. Does anyone have the equation for the graph that was shown? Kristen? You're on the right track. Nate?
Because whenever she descends, she's going down. So it's going to be a negative. So you're starting at 90 and you're subtracting 5 feet per second.
We got the initial value 30 by looking at the graph where it says where from the y graph on the y-axis it's the line starts on 30 and then we find two points on the graph and then we subtract both y's and x's to get our slope, which is our rate of change.
Yes, it's the rate of change. And what is the rate of change? We figured out it is
2.
2. Good job. I'll give you 5 minutes to complete your exit ticket. What did we learn about today? What did we do today? Who wants to start off the conclusion? Thank you, Owen. Go ahead and start it off, and then we'll get someone to add on to it.
In conclusion, we learned to develop strategies for interpreting the slope and y-intercept from a function's graph or equation in the terms of the context, meaning that depending on how the word problem is stated, we have to use that, we have to interpret that to make an equation that'll fit in a graph and a table.
Perfect. Nick, you want to add on to it?
Also, we can figure out the rate of change and through a chart, a graph, or a word problem.
Yes, we have the charts, we have word problems, we have the graph, we also have.
In conclusion, yes, the lesson objective was met. Students demonstrated their understanding through guided practice, independent work, and class discussions. A majority of students were able to accurately solve the problems and explain their thinking and using appropriate math vocabulary, which showed mastery of the lesson goals. Exit tickets and independent practice showed that most students successfully met the objective, with several students exceeding expectations. Students who struggled were identified for targeted small groups support. If I were to do something differently, I would group students into 4 and rearrange desks together. It would be more effective because they promote balanced participation and meaningful collaboration. This group size allows students to share ideas, explain their reasoning, and learn from multiple perspectives without becoming overwhelmed. It also supports peer tutoring, where stronger students can reinforce their understanding by explaining concepts, while students who need support benefit from hearing strategies in student-friendly language. After the teaching segment in the video, a small group in RTI time was held for about 30 minutes, and there are 3 more sessions, and then we will have an assessment on lesson 16. Thank you.